Hello, my young scientists. We are back again, yet we are continuing the chapter on light, shadow, and reflection. In our previous video, we have understood about the sources of light, rectilinear propagation of light, luminous, non-luminous objects, transparent, translucent, and about opaque objects. In today's video, we are going to cover about what is a shadow, how is it formed, what are its requirements, what is reflection of light, what do we understand by lateral inversion of light, and lastly, we are going to see one object which proves the property of rectilinear propagation of light. That is what? That is considered to be a very famous camera, a pinhole camera. Yes. So children, let us start off. A shadow. What is a shadow? You can see how a shadow is formed in this picture. It needs a source of light, an object, and a screen or surface behind the object. What is shadow? A shadow is the area of darkness formed by the object which is obstructing the light. A transparent object does not cast a shadow, remember, while a translucent object forms a very dim shadow. An opaque object is the finest object which can create an absolutely beautiful and clear shadow. Okay. Now, what are the characteristics of a shadow? A shadow is always black in color regardless of the color of the object. It only tells us about the shape of an object but does not give us any detail about it. It is tall, it is having any, not tall, it is having any ridges or not, it is having any pattern on it or not, nothing, no details we are getting in the shadow. The shape of the shadow depends on the shape of the object and the position of the light source. Very, very important thing to remember. For the formation of a shadow, we need a screen, a light. As I mentioned previously, it always requires a screen. It requires a light source and an opaque object or a translucent one. The size of the shadow increases. Remember children, if we decrease the distance between the object and the light source and vice versa. Remember, please remember about this. Moving on to the next part of the chapter or the next topic, that is reflection. When we are talking about shadow, when we are talking about opaque objects, obviously children, we are going to talk about reflection. We discussed about the moon reflecting off the light which it is receiving from the sun in our previous video, if you remember. So the opaque objects always reflect off the light whichever it is receiving on it. It is just the bouncing of light on the opaque object is considered to be reflection. What happens when light is thrown from a torch on a mirror? The phenomenon of change in the direction of light when it strikes on a body or a surface is called reflection of light, the bouncing of nature. You can see that if the light is striking on a smooth surface, we are able to get a very clear or a very profound, a very nice, clear, straight reflected ray. But when the incident ray or the light which is falling on the surface and the surface we are getting is rough in nature, the reflected rays are diffused in form. They are not in a proper format. They are in a haphazard way. They are going in different directions. They are not going in the same direction, if you see. So it depends on the kind of object, it depends on the kind of surface it is getting reflected on. Okay, so remember this. See, one experiment or one activity we can perform. See, we can keep a comb and we can put a mirror behind it, and we can put a torch in front of the comb so that we are able to see the shadow. We have to obviously conduct this in a pitch dark room, children, not in a very well lit room. And when we are putting the torch, we are able to see the shadow the comb is casting. And again, that shadow or the light which is reflected from the comb from towards the mirror and passing through the comb, the light is reaching the mirror, and again a kind of shadow is being formed. So we are observing a kind of pattern, a mesh-like pattern. So we will get this net-like of pattern when the light rays pass through the comb and strike the mirror, and after striking it is forming this net-like pattern on the white sheet of paper. Isn't it fascinating? Now we will be talking about the lateral inversion of light. Have you ever noticed that when we lift our right hand, the image in the mirror lifts its left hand? Or when we write letters on a paper and hold it in front of a mirror, the image formed shows that all the letters are inverted from right to left. This property of left-right reversal of an image in a mirror is considered to be lateral inversion. It's a very, very fascinating kind of a thing which we can see happening when light reflects off on the mirror, and these kinds of things are happening. So we can tell there are few differences between a shadow and an image. Namely, a shadow gives the details, the image gives the details as well as the outline of the object, but on the contrary, shadow will never give you any detail. It only gives the outline of the object. It is formed when the light from the source is blocked by an opaque object, and in case of images, it is formed when light from the object reaches our eyes after reflection. So there is always a very distinct difference between a shadow and an image. Please go through this table. If you want to have a screenshot, you can take a screenshot and you can memorize it. Have you ever noticed how the word ambulance is written on an ambulance? It is not written in a straight way. It is always written in a ulta way, on an opposite direction. Why is it so? Because when a car is speeding up, it can see in its rear view mirror that an ambulance is coming at its back, so that the ambulance is read properly from left to right. Therefore, it is written in the right to left fashion, so that when the driver is reading the image, it can read it clearly. Because of this lateral inversion property, they are doing this purposely. Okay. Lastly, we are having the pinhole camera. The pinhole camera is the simplest camera without a lens. It consists of a light-proof box with a tiny hole on one of its sides. The light falls on the pinhole, forms an inverted image of the object on the opposite side of the box, and it is based on the rectilinear propagation of light. Smaller the pinhole size, the sharper will be the image. If you see, children, they have given this picture of the pinhole camera. See, the object here is a balloon, and when the light rays are passing through the pinhole, it is giving an inverted image. Why is it so? Because we have learned that in rectilinear, a property of light is rectilinear propagation. The light which is passing from the pinhole through the pinhole, it can never change its way. It can never change. It can never go right or left. It is always bound to travel in a straight line. Therefore, the light from the top of the object is reaching towards the bottom of the screen, and the light from the bottom of the object is reaching the top of the opaque screen. Therefore, the image becomes inverted when we are seeing it from the other side. So this is one very, very unique property and one very interesting thing we can see in pinhole cameras. Okay, we can see the exactly same thing happening in our own eyes, children. Whatever image which we can see, it is formed in an inverted way. It is forming an inverted version in our eyes on the retina, okay, of our eyes. After the inverted image is formed on our retina, the retina is sending some signals to the optic nerve in our eyes, and the optic nerve is processing it and changing it into a, it is again changing it, and it is giving us the straight image we are able to see in front of us. So everywhere in our eyes, in the pinhole camera, the function or the property of light remains the same. Okay, so this was all about the chapter light, reflection and shadow. So this is a summary what we have studied in this chapter. Objects can be transparent, translucent or opaque. Light travels in a straight line. Shadow is formed when an opaque or translucent object blocks the light falling on it. A shadow is always black in color regardless of the color of the object. Rough surface reflects the light in different directions, while a smooth surface reflects the light in one and only one direction. An image shows the color, outline and details of the object. And finally, a pinhole camera is based on the property of light to travel in a straight line. So, thank you children. Thank you for being there. I hope you all are not having any doubts. If you are having any doubts, please comment down in the comment section. I will try to solve your doubts. Until then, until we start off any other chapter, thank you. This is Srishti ma'am, your science teacher, signing off. Bye.